welcome back to the online course on analog integrated circuits. Today we will discuss another application of IC 555, that is monostable multivibrator. Here we can see some of the previous year questions from KTU B.Tech examination. All are direct questions like to explain the working of monostable multivibrator and derive the pulse width or duration of the pulse. Also, we can expect some of the design problems also. Let us look at IC 555 monostable multivibrator now. Monostable multivibrator is a pulse generator circuit in which the duration of pulse is determined by the RC network. As the name indicates, monostable multivibrator has one state of the output is stable while the other is quasi-stable or unstable. In order to have a transition from stable state to quasi-stable state, external trigger pulse is required. Here, a trigger input is required to be applied to pin number 2. Generally, a negative going pulse is used as a trigger. Let's understand the circuit of monostable multivibrator. Here is the circuit. The threshold input is connected to capacitor going to ground and a resistor which is going to VCC. And threshold and discharge are connected together. At the pin number 2, that is trigger, as I said earlier, a negative going pulse is applied as trigger to change the output from stable state to quasi-stable state. Output is taken from pin number 3 and pin 5 is grounded through a 0.01 microfarad capacitor to avoid noise problem. Here is the circuit with the internal circuit of IC 555. Here, voltage at the point P, Vp is equal to 2 VCC by 3, and the voltage at this point Q, Vq is equal to VCC by 3. As we learned in the working of IC 555, for getting low output, threshold must be greater than 2 VCC by 3, and for getting high output, the trigger input must be below VCC by 3. Here the capacitor is only connected to the threshold input, hence we will only have the auto transition from high to low. In order to have a high output, we should apply a negative going pulse at the trigger to make trigger input less than VCC by 3. Hence, we can say that here the low output is the stable state and high is the quasi-stable state. Let us move on to the working of monostable multivibrator. Initially, when the output at pin number 3 is low, that is circuit is in stable state, the flip-flop output Q is high and the transistor is in saturation or the transistor is on. Hence, the capacitor is connected to the ground through this transistor. When a negative going pulse is applied to pin number 2, the trigger input falls below 1 by 3 VCC, the comparator 2 output goes high, which resets the flip-flop, hence Q become low. So the output become high and the transistor turns off. This is the transition of the output from stable state to quasi-stable state. As the discharge transistor is in cutoff, the capacitor C begins charging towards VCC through the resistance Ra with a time constant equal to Ra into C. When the capacitor voltage exceeds 2 by 3 VCC, the output at the comparator 1 goes high, which sets the flip-flop. Hence, the output becomes low and the transistor goes into saturation. Thereby, the capacitor will discharge rapidly to 0 volt. Thus, the output returns back to the stable state from quasi-stable state. The output of monostable multivibrator remains low until a trigger pulse is again applied. This is how the pulse is generated in monostable multivibrator. Here, the pulse width depends on the time required to change the capacitor from 0 to 2 VCC by 3. In other words, the time constant Ra into C controls the width of the output pulse. Here you can see the waveforms. Suppose initially the output is in low state. When a negative trigger pulse is applied, the output becomes high and the capacitor starts charging towards VCC. When the capacitor voltage reaches 2 by 3 VCC, the output becomes low again. Let's derive the width of the pulse. As we see earlier, the voltage across the capacitor in an RC circuit can be modeled as Vc of t is equal to V final minus V final minus V initial into e raised to minus t by tau. Here, the capacitor is charging towards VCC from 0, hence V final is equal to VCC and V initial is equal to 0 and the time constant tau is equal to Ra into C. Then the capacitor voltage will be Vc of t is equal to VCC minus 0 into e raised to minus t by tau, or Vc of t is equal to Vcc minus Vcc into e raised to minus t by tau. Here Vcc is common, hence the equation becomes Vc of t is equal to Vcc into 1 minus e raised to minus t by tau. At t is equal to capital T, that is duration of the pulse, the capacitor voltage will reach 2 by 3 VCC. Apply this condition in the above equation, hence the equation becomes 2 by 3 VCC is equal to VCC into 1 minus e raised to minus capital T divided by tau. Here VCC can be cancelled from both sides, hence the equation becomes 2 by 3 is equal to 1 minus e raised to minus capital T divided by tau. Take this term towards LHS and take this 2 by 3 towards RHS, then e raised to minus capital T by tau is equal to 1 minus 2 by 3, or e raised to minus capital T divided by tau is equal to 1 by 3. Take natural logarithm on both sides, then equation become ln of e raised to minus capital T divided by tau is equal to ln of 1 by 3 and ln of e raised to minus capital T divided by tau is equal to minus capital T divided by tau and ln of 1 by 3 is equal to minus 1.0986. Hence, it becomes minus capital T divided by tau is equal to minus of 1.0986. Again, negative sign will be cancelled from both sides, hence it becomes capital T divided by tau is equal to 1.0986. Take this tau towards RHS, then the equation becomes capital T is equal to 1.0986 tau, or we can write T is equal to 1.0986 1 into Ra into C. So the duration of pulse or pulse width is equal to 1.1 into Ra into C. This is how we can derive the duration of pulse, or we can show the pulse width is depending on the resistance and the capacitance value. Take an assignment. Here is the question. Determine the output pulse width for the monostable multivibrator when Ra is equal to 20 kilo ohm and C is equal to 0.1 microfarad. Let me stop here today. I will continue in the next class. Thank you.